Okay, so in this lesson, we are going to use constant rate of change, or our slope. So we're going to use our slope to make predictions. Okay, so in this first one, it says, what is the predicted distance after 12 minutes? So we have this line full of points, dot, 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 and we're going to figure out where it would be after 12 minutes. So the first thing I would do is, well, before we even start, I'm going to show you two methods. Okay, I'm going to show you how to do it using a table and how to use it doing like the direction method that we used before. So I'm going to write some nice, or show some, identify some nice integer points. So let's make a table. The distance is the topic, so distance. So make sure you write that and change, and that's the time. And so we have 0, 1. We have 3, 2. And we have, okay, better. And we have 3, 4, 5, 6, 3. And we are trying to get to 12 minutes. So let's do change in distance over the change in time. So the distance increases by 1 when the time increases by 3 minutes. So distance increases by 1 mile every 3 minutes. A little better, okay. And then so we're trying to get to 12. So it goes 0, 3, 6, 9, 12. So plus 3. I can write that a little better. And then plus 3 again. And then this is just plus 1, plus 1. So we get 4 and then 5. So this right here is where our solution is. So after 12 minutes, the distance is 5 miles. That's not bad. Now, but that, I don't know, it's kind of cumbersome in some ways if you don't have to do it. Like, it's kind of annoying a little bit. I mean, it's fine, it's good, it works. But let's try to get to 12 using the graph. So this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm trying to get here. So up 1, right 3. Up 1, right 3. Up 1, right 3. So I'm at 9 minutes. And up 1, right 3. So this is where I'm trying to get to. Well, this is the location of the point that shows 12 minutes goes with 5 miles. So I'm just going to show that I went up 1, right 3, and then it moved into, well, it got me to 12, 5. 12, 5. Okay, so assuming the constant rate of change continues. Assuming that it continues, like in the same way, like showing it in the table and showing it with directions. After 12 minutes, the distance will be 5 miles. So you should be able to see it here, the answer here, and then you should be able to see the answer here. Like that. So let's try the next one. So what's the predicted cost of 8 pounds of food? So cost in dollars, pounds of food. So the cost for the food, and we only have this nice integer point, this one. So 0, 1, 2, 3. So 0, 3. And this is counting by 3. So 0, 3, 6. Always be careful. These aren't always going to be counting by 1. Okay. So 0, 3, 6. So 6, 4. And I'm trying to get to 8, which sounds a little off. Yeah. So let's change this. Let's change. I think this is supposed to be 18. So I'm actually going to cross out like that. This should be 18. Okay. 18 pounds of food. So the change in cost with the change in food, the cost will increase by $1 every 6 pounds of food. So that should be 1 more with 6 more pounds of food, and 1 more after 6 more pounds of food. So this 0, 6, 12, 18. So that's 18 pounds of food. Yeah. So I'm gonna box this one. Okay. And so we have our answer here. Let's find our answer using the graph method. So 18 pounds of food. So 0, 3, 6, 9, 12, 15, 18. Okay, that's 18 pounds. So remember, we're going up 1, right 2, but it's actually right 6. So, but up 1, right 2 spaces. Up 1 space, right 2 spaces. Up 1 space, right 2 spaces. And that's right there. Which is 18, 6. Let's try that again. I don't know why it's not letting me draw this. Okay, there we go. So that is 18, 6. And we kept going up 1 and then right 2 spaces. But I don't want you to write right 2 spaces. I want you to write 6. Went up 1, right 6. Remember 6. And then that got us to 18, 6. So assuming the constant rate of change continues, 18 pounds will cost $6. And one more. So what's the predicted temperature after 16 seconds? So let's not find these. Okay. And temperature with time. So we started at 0. Oh, these count by 3, 6, 9, 12, 15, 18, 21, 24. This counts by 2, 2, 4, 6, 8, 10. So 0, 24. 0 seconds, 24 degrees. 4, 21. And 8, 18. And change in degrees Fahrenheit, and this is change in, we'll put change in T for time here. So this is a decrease of 3, decrease of 3, and the time increased by 4, when the time increased by 4. So we're trying to get to 16 seconds, so plus 4 is 12. And then plus 4 is 16. And this is minus 3. Minus 3. So that gives me 18 minus 3 is 15. Minus 3 is 12. That's my solution. Let's see how I would get that on the graph. So I go down 3. Remember, that's really 3. Right, now that's not 2, that's actually 4. So down 3, right 4, down 3, right 4, down 3, right 4. Let me make sure I know where I'm getting to. 16, 12, 14, 16. So one more. And that would be 16, 12 once again. So I went down, not one, it was one space, but it was worth 3. Right 4. If you notice, this will match here. Like the down 3 is negative 3, and the right 4 is the plus 4. So after I did all that, I ended up with 16 seconds goes with 12 degrees Fahrenheit. So assuming the constant rate of change continues, the temperature, we'll spot the whole thing, the temperature will be 12 degrees Fahrenheit at 16 seconds. And that's it. Thank you.